Our emphasis has been, and will be, on functions and functional programming, but it's also helpful to know at least something about classes and object-oriented programming. In general, an object consists of both internal data and methods that perform operations on the data. We have actually been using objects and methods all along, such as when working with built-in types like lists and dictionaries. You may find at some point that an existing object type doesn't fully suit your needs, in which case you can create a new type of object known as a class. Often it is the case that even if you need to create a new object type, it is likely that this new object type resembles, in some way, an existing one. This brings us to inheritance, which is a fundamental aspect of object-oriented programming. Inheritance means that you can define a new object type, a new class, that inherits properties from an existing object type. For example, you could define a class that does everything that Python's built-in lists do, and then add an additional method or methods based on your needs. As a quick reminder of how we've been using methods so far, let's define a list ML, which consists of a sequence of numbers. If I wanted to sort this list, I can use the sort method, which is provided by the ML object, a list. If I now look at the contents of the list, we can see that the values have been sorted. Let's look at an example of how to create a new class, essentially a new type of Python object. A class is defined using the class statement. Class myList and colon. The name of the class, in this case myList, immediately follows the word class. Notice that we place parentheses after myList. This is how Python specifies inheritance. When a class is created via inheritance, the new class inherits the attributes defined by its base class, the class it is inheriting attributes from, in this case a list. The so-called derived class, in this case myList, can then both redefine any of the inherited attributes and, in addition, it can also add its own new attributes. You can think of the class statement as setting up a kind of blueprint of a new class. What that means is that it specifies the internal structure of these new types of objects, including what methods and operations they support, but it does not create any object of that type. When an object of a particular type is created, that object is sometimes called an instance of that type. So another way to state what I just said is that the class statement doesn't create any instances of the class. This is a bit like defining a function with the def statement. The function definition specifies what the function does when called, but defining a function does not, in itself, call or invoke that function. That's something you would do outside of the function's definition. That's why it's helpful to think of the class statement as defining a blueprint of the new class, a new type of Python object. Our class makes use of the min and max functions, as well as the list remove method, so let's review those briefly. Here we have a list set up called x. I can use the min function to find the smallest element of the list x, in this case the number 2. Similarly, I can use the max function to find the maximum element of the list, here 11. Let's also remind ourselves how to remove elements from a list. The method remove does precisely that, and it takes just one argument, which is the value that you'd like to remove from the list. One thing to note is that if the given value appears on the list multiple times, only its first occurrence is removed. Continuing with our list x, one of the elements on the list is number 10. So if we type x.remove 10, and we look at the list again, we can see that the number 10 has been removed from the list. Let's look at the class definition that I've just completed on my screen a bit more closely. You can see that it contains two def statements that are used to define functions. The functions defined inside a class are known as instance methods because they operate on an instance of the class. By convention, the name of the class instance is called self, and it is always passed as the first argument of the functions defined as part of a class. Here we define two functions, two instance methods, which we call removeMin and removeMax. Looking at the removeMin function, we see that it only consists of one line. We first use the min function to find the smallest element of the list. We then use the remove method to remove that element from the list. The function removeMax works analogously, except that instead of the min function, we have the max function inside the parentheses. Let's then demonstrate the use of our newly defined class myList. I'm going to define a Python list X consisting of a bunch of numbers. I'm then going to define an object Y, which is a myList, and it contains a copy of all of the numbers in X. Remember, we can use the dir function to ask what methods are available for any given object. In this case, X is a standard Python list, so it supports all of the methods of Python lists. We can then do the same for our object Y, which, remember, is the class we wrote ourselves. Here, if you look at the last couple of lines, you'll see that the methods removeMax and removeMin are now available. We can use these methods. So let's type y.removeMin. And if we then look at the contents of Y, we'll see that the number 1, which was the smallest element, has disappeared. It has been removed. If we then use the removeMax method, and we again look at the content of Y, we'll see that the largest element, number 10, has been removed from my list.